There we go. Hey, hey. That's I get to your case because then I will remember to fix it. All right, so this is algebra stuff that I just want us to kind of think through because we're going to be using it in what we're working with today. So things to remember. Simplifying each of these things. So looking at our lefty left one here, we've got, whoa, not the laser pointer, 2x squared times 3x cubed. What will we get if we simplify this?
6x plus 6x squared, 5.
Yeah. So our numbers are multiplying together. My 2 times 3 is going to give me 6. When we multiply the bases on these things that have exponents, what do we do with those numbers? Add them. 2 plus 3. So this one would wind up being our 6x to the 5th, x to the 5. So when we multiply our bases, we add our exponents. What does a negative exponent do? This guy. It does not make it negative. All right, so I was like, if we don't remember, that's fine. So I'm gonna do a thing to help us think through and figure it out. What's 2 to the first? 2. What's 2 squared? 4. What's 2 cubed? 8. What's 2 to the fourth? 16. You guys working on stuff. Never mind. They're working on next door stuff. They ain't knocking. Yeah. So hang on a second, let me write this down. 2 to the fourth gives me 16. When we were going up, what was happening from here to here to here to here? Multiplied by 2. So if I wanted to go down, so this is, we went times 2. This guy was times 2. If I wanted to go down, what could I do instead? Divide by 2. Divide by 2. So we're getting there. So if I'm at 2 to the first, and I want to go down to 2 to the 0, if I divide by 2, 2 divided by 2 gives me what? 1. So I'm going to go down again. 2 to the minus 1. I need to divide by 2. What's 1 divided by 2? 1/2. 2 to the minus 2. 1/2 divided by 2. Because I think if I have half a pizza, dividing it among 2 people, they each get 1/4 of a pizza. 1/4. So then look at these in pairs. What's the difference between 2 to the first and 2 to the minus 1? They're reciprocals. What is the difference between 2 squared and 2 to the minus 2? They're upside down from each other. So what the negative exponent does is makes it change which side of the fraction it's on. If it's on the top, it's going to go upside down into the denominator. So the negatives, it's the same value. It makes it do a reciprocal, because I heard that one come out too. So if we had 6x to the minus 2, what are we going to wind up with? Does the 6 have a power on it? Or is the 6 just a number sitting next to it? Just a number sitting next to it, being weird. And my x squared goes down here. So it's still that same value, just like we had our 2 squared. Still became 4. It's still being squared. It just goes in the bottom. So a negative exponent makes it go into the bottom. What about for this one on the right? If I have powers over powers.
Isn't that when you multiply it?
Mm-hmm. This is the one, it feels a lot like distribution because I need to make sure the 2 gets multiplied too. Because this is the same thing as if I had 2x squared times 2x squared times 2x squared. That's what it means for them to be cubed, right? So I have 2 times 2 times 2, also known as 2 cubed, and x squared times x squared times x squared, so x squared cubed. Which I also already heard us point out that the 2 cubed gives us 8, x to the 2 times 3. So what's this simplify down to be? 8x to the what? 6. So powers over powers multiply. Negative exponents go down in the denominator. And when we multiply our bases, we add our exponents. It's not going to come up super duper frequently in what we're doing today, but there are things that will come up, so we are going to need to know them. Okay? Because what we're going to work on today is we're going to start taking things more like the equations we wrote on Thursday and work towards solving them. Not just plug, chug, put in calculator, actually solve figuring out what a value is. So we're going to be given problems that look kind of like these guys. So we have our very first one is 2 to the x equals 2 cubed, and we're asked to solve. When we are given the word solve, what that means is we want to get down to x equals all the way down. So look at this first one. 2 to the x equals 2 cubed. What does the x have to be for those have to be equal to each other? 3. The only thing the x can be that will make these two things be equal to each other is 3. If x is anything but 3, they do not equal each other. So what we're looking at here is as long as our bases are the same, since I have a 2 to the x and a 2 to the third, I can look at just my exponents. I want to know when this x exactly equals that exponent 3. And in this case, that's all we had to do. That's our first solution. When our bases are the same, we're setting our exponents equal to each other. So then we have this one over here. Smidge more. Now we have 3 to the x minus 2 equals 3 to the 7th. It is not going to be 12. It is going to be 9. My bases are the same, so the 3 to the part doesn't make any difference. In order for these statements to be the same, this guy has to exactly equal this guy. X minus 2 has to equal 7 in order for them to equal each other. It's just how it works. And we can put it back in and test it. Because what do we do to finish this out? Well, that would be testing. How do I get x by itself? Add 2. Plus 2.
Oh, you really do.
Yeah. Finishing solving it. X equals 9. And then if you want to test it, you absolutely can. 3 to the 9 minus 2. Well, 3 to the 7 is exactly what 3 to the 7 is. So it gives us the exact same statement. Whether or not we care what 3 to the 7th is, they mean the same thing. So it's all about finding whatever piece is going to make our exponents be the same. But we have to have our bases the same. What's up? Okay. All right. To be fair, these are the easiest ones today. So, now we're going to get a smidge harder. Every page you're going to kick up a notch. So here we have 4 to the 2x minus 3 equals 4 to the x plus 5. I want to know when these two statements are equal to each other. I want to know what x makes these equal. Again, my bases are the same. So 4 to the 2x minus 3 and 4 to the x plus 5. So in order for these two things to be the same, these two exponents have to be the same. So our 2x minus 3 has to equal x plus 5 for these two expressions to be the same thing. So we have to set them equal to each other. Where can I go from here? I heard like 4 different ideas that all happened at the exact same moment.
Add 3.
Add 3? That's one of the options. We have lots of ways through it. So we'll have our 2x equals x plus 8. Then what? Minus x. That's going to leave me with what? Equals 8. And if you substitute that back up in here, that'll work. 2 times 8 gives us 16, minus 3 gives us 13. 8 plus 5, 13. They equal each other. 4 to the 13 is the same as 4 to the 13th. So if we give it to you with our bases already the same, set your exponents equal, easy peasy. And we're not always going to give you to when they're the same.
X equals 0.
Look at the one on the right. 3 to the x equals 27. What do we know about 27?
It's the cube of 3 squared.
It's the exact same thing as 3 cubed. 27 is 3 cubed. It is. So I could rewrite this 27 as 3 cubed. When does 3 to the x equal 3 cubed? When x is what? So whenever we're working these and we don't have our bases the same, we have to make our bases be the same. And if we do not have one that we can make our bases the same, at this point we do not have what it takes to solve it yet. Okay. Questions on this one? Or these two? Y'all are squirrely today. Next couple.
Did you write this one?
I changed it because it wound up with 2 problems in a row that had 27.
Guys, I think that over was 27 as well. Nah. You never guess, because like.
No, like seriously, dude, we just did one that had 27.
No.
I'm putting it back here. What's up? If that's the question we're given. I just wrote it in there. Because the typed one I didn't like. I changed it. That's the problem we're given. Can I write this as a multiple of 3? What is it? Yeah. 81 is the same thing as 3 to the 4th. So I can rewrite 81 as 3 to the 4th. That's going to give me 3 to the x plus 1 equals 3 to the 4th. Yeah. Because we're going to take now our exponents and figure out when they equal each other. X plus 1 equals 4 minus 1 on both sides. So we get our x equals 3. Okay. There have been. Mostly because we don't want these to be obnoxiously big numbers. We generally pick numbers that we will at least be able to figure out the multiples of. We're not super mean about it usually. I could give you really worse ones. I was gonna say we could do 2 to the like 128, which would be a lot. All right. So let's look at the one on the right up here. We've got 2 to the 2x equals 8 squared. So a little bit more. We'd really, really, really like our bases to be the same. It's the only way we can do something with it. So can I write 8 using just 2's? 2 to what power is 8? 2 cubed is 8. Everything else is staying the same. 2 to the 2x equals 2 cubed and then squared. What can we do to simplify this? Play a game does not answer this question.
The power rule.
The power over powers. Oh, snap. The stuff we remembered right at the beginning. What do we do with those two exponents?
We divide them.
Not divide. We multiply. So this is going to be, my right-hand side is going to be 2 to what power?
6.
So 2 to the 2x equals 2 to the 6. So then, no.
Why did you do it earlier in the middle?
So, as I said, I can't actually hear you. So, take our two, now that we have our bases the same, take our two exponents. My 2x, I want to know when that equals 6. 3. Divide both sides by 2, so x equals 3.
I think there's a lot of 3 actually.
Yeah, there's been a lot of things.
There's been a lot of 3s.
Well, it's like
Like
they're all
3 is not my
connected.
lucky number, but it's more than I will make it my lucky number.
Mm-hmm.
3 is like cubes, and the end it's like
I think
a
it's.
sign.
I think the sign.
This-
I put
this
all
3
in
here?
today.
Yeah.
This one you're looking at? Because we needed to write it so that my 8 was got a base of 2. So we looked for our 2s. 2, and we did our whole list of 2s. Boop, over here. 2 to the 3rd is 8. So we can use this to change this so we have that same base. Because we got to have the same base if we're looking at our exponents to equal each other. We have to have the same base. And not until next chapter. Next chapter, we're going to have another way to do this, but I don't know that you'll be happy. Just in general.
It's a sign you gotta gamble $3,000.
Yes. Yes.
Here's our next one.
Appreciate you.
Yeah. We have 2 left. This one and one more. So they're going to be slightly more. So now we have 4 to the 5x plus 1 equals 64 to the 7. So we need things to have the same base. What can we do? 64 is a power of 4. 64 is 4 cubed. So I can rewrite this as my 4 cubed. It's still to the 7th, and the other side hasn't changed. My 4 to the 5x plus 1. What do we do next? More specific. Multiply the 7 and 3. We've got powers raised to powers. So I need to multiply the 7 and the 3. So this is going to become 4 to the 5x plus 1 equals 4 to the what power? 21. What are we going to do from here? Yep. Now we're looking at these exponents. My bases are the same, so I get to ignore them. Now that my bases are the same, we can just look at our exponents. When does 5x plus 1 equal 21? What do we need to do? Subtract the 1. We get 5x equals 20. Yeah, divide both sides by 5, and we get that x equals 4. Okay. And if you go back up to the top and substitute it back in, it'll totally work. Okay. One more.
Last one of the day.
Last one of the day.
Yeah, cake number.
Thank the Lord. No, chill. You gotta gamble.
Just gonna say chill before you say that.
Watch it be a thing. This is very. See, at this moment, this is what most people do.
Last one. We got 1/2
Like I'm not.
to the
half of
4x
4x
minus
16 equals 16x.
Okay,
No,
hold on.
16.
to the 2x
2x
minus
squared.
5.
I get it. You gotta.
Like, y'all just making up stuff.
It's what? 5.5.
We would like to get everybody to have the same base.
Too much work.
What kind of base do we think 1/2 and 16 might have that's in common?
2.
2.
Oh.
Think there are 2s. We did our list of 2s earlier. Is 1/2 on the list of 2s that we looked at? Here we go. Let's look over here. Come on.
Yeah.
Is 1/2 on here? Is 16 on here?
Yeah.
So we could put these both in terms of 2s. Because 1/2 is 2 to the minus 1. So we're going to have 2 to the minus 1 to our 4x minus 16. And our 16, that was 2 to the 4th. With our 2x minus 5. So when we have pieces that have chaotic looking bases, see if we have something that's a very common factor of them. With our fractions, look at the denominators, because we really like this to not have to be there. So now that I have 2 sets of these powers over powers, what are we going to do with each of them? What do I need to do when I have a power raised to a power? What do I do with the 4 in this chunk out here? Multiply. So this is the same thing as if I had 2 to the 4 times 2x minus 5. And my left-hand side is like 2 to the power of minus 1 times 4x minus 16. Now that I have my bases the same, I can ignore them because all I care about is when those exponents are the same. So when I come down and write down just my exponents, I'm also going to do this multiplication. What is minus 1 times 4x minus 16?
Negative 4x plus 16.
Minus 4x plus 16. And then we distributed the minus sign through. On the right-hand side, my 4 times quantity 2x minus 5.
8x subtract negative 20.
8x minus 20. So I did the multiplication and brought them both down into the same line. Where can I go from here?
Add 4x.
We can add 4x to both sides, totally fine. Get our x's together. There are many, many pathways through at this point, so if you take a slightly different route but wind up at the same answer, you're probably fine. So 16 equals 8x plus 4x gives me 12x minus 20.
Add 20 to both sides.
Add 20 to both sides, so we get 36 equals 12x. We're almost there.
Then you get x equals 30.
I say divide both sides by 12, and we get that x equals
I'm gambling with 3 today, guys. All of 3.
all the 3's. Mostly we're just trying to make it so the numbers aren't like gargantuan, because they get too big in exponentials. They get really big really fast. So if we go much higher than like 3 or 5, we wind up with several thousands. And then it just becomes a matter of can we type things in the calculator accurately. Okay, so that gives you everything we need to be able to finish out question 7 on homework 1. That was all we had left on homework 1. So that's all the pieces we need for it. What's up? Question? That would be part of the reason we looked at the minus over here.
How do you know about this too? Like,
Anything that is a minus exponent scooches down. So over on this one, with the 1/2, I could straight up write 1/2 as 2 to the minus 1. If I get 1/3, I can write that as 3 to the minus 1. If I get 1/4, I could write that as 4 to the minus 1 or 2 to the minus 2. Whichever one helps me more, because 2 squared is 4. To flip it, I can make it negative. These two things, again, are equivalent, just like 2 squared and 4 are the same thing. So anything that's a fraction, we can put it as a, whatever the denominator is, to the minus 1. Okay, good question, guys. So we've got SAT coming up on Thursday. Homework 1, you guys can now finish out. There was only 4 questions that had solving on them on homework 1. So you can finish that out. Tomorrow we're going to move on with what we doing. We're going to work with some more banking style questions. Yes, because you got more things to do. All right. So that's kind of the vibe. You guys have 10 minutes where you can work on stuff, ask questions, all that jazz. All right. So now's a great time to work on maybe catching up on some homework. If we have anything that's missing, now's a great time to start looking at that. If you have any missing quizzes, we can look at those. Huh? A Friday? That's when our chapter test is? Next Friday? Yeah. You want to come in during test, is there? Yeah. What period do you have study check? C. Do you have D lunch? Okay. Just knowing so I can hopefully be in here because I should remember. I'm going to do my best. Yeah, give me a second. Here you go, Desire. All right, Rashawn. Rashawn, go fast because you're like at the threshold for when I'm allowed to.
Oh, sorry.
No, it's okay. I was like, you're right at the threshold though, so don't make bad choices or I'll get in trouble. I don't like that they give me rules on those, but then, you know. All right, let me get our attendance fixed. Tuesday last week was the time when I was out. So you guys have like worked on your chapter review.
And then Wednesday was our chapter.
Was the chapter test or the quiz? Which the quizzes are graded in, and I would let you look at them, but I forgot the file folder with them at home. So I will have them here tomorrow. I'm gonna forget my home.